Hello everyone, this is Sylvain Laborde speaking from the German Sport University Cologne in Germany. Today we are going to talk about a specific relaxation method called slow-paced breathing that one can realize with or without the help of a technical device providing biofeedback via a smartphone, for example with the app that you currently see on the screen. So, also called heart rate variability biofeedback, this method is used as an adjunct treatment for a large range of psychological and medical conditions. And we are going to try to clarify its underlying mechanisms with the following study. So, to set the stage, slow-paced breathing is a relaxation technique aimed to decrease your breathing frequency to 6 cycles per minute, knowing that your spontaneous breathing frequency is comprised between 12 and 20 cycles per minute. Several mechanisms are thought to be responsible of its positive effect. And for the first one, we are going to focus on the vagus nerve, given we will be able in this study to measure what is called cardiac vagal activity, a marker of self-regulation, a marker of the connection between the heart and the brain. And measuring heart rate variability, we will be able to get an insight into this cardiac vagal activity. Next, biofeedback. Biofeedback is the display on screen, smartphone in this case, of a physiological parameter such as heart rate, such as any HRV parameter, or also the respiration signal. The reason for using biofeedback are the following. First of all, it can be part of a protocol to determine what is called the resonance frequency. Then it can be used to increase the effectiveness of the slow-paced breathing exercise. Finally, it can be used to monitor the effect and be used as an operant conditioning protocol. Now the question, does this fancy technical device add anything to the effects of slow-paced breathing? So far, we only have one study who addressed this question, Wells and colleagues in 2012, and they found no differences between subjective parameters linked to anxiety and regarding those related to cardiac vagal activity. Consequently, we wanted to clarify with this study if biofeedback used as a monitoring purpose can provide an added value to the classic slow-paced breathing exercise. Our hypotheses were the following. Reading cardiac vagal activity, actually we expected no difference between conditions. Reading subjective variables, we did expect that the fact that visualizing the effect on the screen of a smartphone of slow-paced breathing via the biofeedback technique would help to perceive a more positive emotional valence, to decrease emotional arousal, to increase emotional control, and to lower perceived stress. For this study, we tested 112 participants. I'm going to show you the slow-paced breathing exercise. Actually, we can do it together. So the goal was to inhale when the little yellow ball was going up and to exhale when the little yellow ball was going down. Okay, let's try to do it once together. So, inhaling and exhaling. All right, so they had to do this for 5 minutes. And we compared those 5 minutes realized alone only with this pacer or realized with this pacer plus with a biofeedback device. We measured cardiac vagal activity with this small ECG device, the Pharos 180 degrees from Bittium, and we analyzed data with the Cubios software. The biofeedback material was the following. We used the Polar H7 belt coupled with the smartphone app Elite HRV. Regarding perceived subjective states, we used the self-assessment mannequin to assess the valence, the arousal, and the emotional control. For perceived stress, we use the visual analog scale. The next slide will show you the protocol we used in this study. So basically, it was a within subject design, so our participants were doing both conditions with or without, so slow-paced breathing with or without biofeedback. Let's come to the results now. Regarding emotional valence, we expected the biofeedback condition to provide a better experience. Well, we got no differences between the conditions, and in both cases, the emotional valence decreased. How can we explain that? I will couple a bit the discussion here. Given actually, the first time you do it, it may be a bit uncomfortable to perform slow-paced breathing with or without biofeedback, meaning that it requires some training, and also we need to instruct the participants not to hyperventilate in order to avoid this discomfort. The next point regarding emotional arousal. Here again, no differences between the conditions. In both conditions, we had a similar decrease of emotional arousal during the slow-paced breathing condition, either with or without biofeedback. Regarding emotional control, here again, we thought that providing the biofeedback would help the participants to feel at least more in control of their emotional states. And here we saw an increase in both cases, but the increase was not different between the conditions. Regarding perceived stress intensity, again, no differences between the condition. It decreased both in the condition with and without biofeedback. Finally, regarding cardiac vagal activity, here operationalized via RMSSD. Again, so this time our hypothesis is validated because we actually expected it based on the Wells and colleagues study, 2012, that we would observe no differences between the studies. We can see here on the graph the classical increase in terms of cardiac vagal activity during the slow-paced breathing with or without biofeedback, but no differences again between the conditions. So, how can we explain our results? Basically, to sum up, we found no differences between slow-paced breathing realized with or without biofeedback. On all levels, reading the subjective variables, emotional valence, arousal, control, or passive stress, or reading cardiac vagal activity. Well, actually, this would point towards slow-paced breathing itself being the core mechanism, and biofeedback here, even if we may have intuitively expected at the beginning due to its monitoring purpose that it would have helped to at least reinforce the subjective experience, well, in our study, it did not. How can we explain this? So I will directly go to our limitations and the fact that we only investigated 5 minutes. And it's possible that if we would have taken a longer period, like 10, 15, or even longer, then perhaps biofeedback would have made a difference, because just doing the slow-paced breathing exercise without getting any feedback of what's happening in the body may have been perceived as perhaps not so motivating after some time. The other thing that we can say is that actually biofeedback has several purposes, and monitoring is one of them. But there are actually other purposes to biofeedback, and it could actually be used also to improve the slow-paced breathing exercise, in the sense that with biofeedback, you could aim to increase the oscillations, the so-called respiratory sinus arrhythmia, to also try to increase the benefits you can get from slow-paced breathing. So definitely, further research has to address this issue. Take-home message is that slow-paced breathing, even without biofeedback, if we're talking about a short period like 5 minutes, can already help to optimize psychophysiological parameters. For athletes, it means that it could then provide a nice help to self-regulate, to manage your stress before competitions, also during competitions when you get breaks, for example. All right, I hope then that this study was interesting for you and that you may have taken some motivation from it to try yourself slow-paced breathing with or without biofeedback to get your own opinion on it. Thank you very much for your attention, and I'm open to questions now. Bye-bye.